Okay, good morning again. This is Professor David J. De Los Reyes. Okay, my topic for this session will be a long video format lecture on college algebra. Okay, we are running smooth on our long video format college algebra. Okay, let's proceed. Our lesson for this morning will be college algebra lesson number 19. We are running smooth, okay? And the title of the topic for this morning will be special products. Oh, this is an easy one. It's just the multiplication thing, right? But since we are discussing the long video format, we must have to introduce the concepts of special products or special multiplication process. Okay, let's proceed. There are actually one, two, three, four topics for special products because I segregated the other topics so we will not overload our mind. Okay, so for this morning it's just only special products. Okay, number one, uh, classification of special products. The product of two binomial. Okay, product of two binomial meaning if we try to multiply two binomials. Okay, what is a binomial? A binomial is actually an algebraic expression involving two terms, uh, including the plus or minus sign in the addition of the terms, right? So binomial is an expression, algebraic expression which contains two terms, okay? Let's try to bring out the form of a binomial. The form will be something like this, okay? This is the first binomial and this is the second binomial. So the letter designations are all different, so we could visualize their differences, okay? The product of this W plus X times the quantity W plus Z. This is actually a very easy thing, because to find the product of this, we will just use the so-called distributive law, right? So if we try to expand this one, okay, this is just a matter of discussion now because we've been doing this for so many times already in our simplification. So if we try to multiply this one, okay, we will cover the second one. So we will place W times the second binomial. We will cover the first term on the first binomial multiplied by the second binomial again. Okay? That's the proper way how to multiply this one. So there's no big deal over here. So this is now just a matter of discussion. Okay guys, don't be bored. This is just a very simple one for the product of two binomials. So if we try to expand this, we know how to distribute, right? Distributive law under college algebra. Previous topics. So this should be Wy, Wz, plus the product xy, plus the product xa, and that's it. Okay? That's how we multiply two binomials. Okay? You just expand using your distributive law, and you know your fundamental operations. Okay? So you could actually bring out the expansion. Product of two binomial or the expansion of two binomial. An example problem of this is find the product of the quantity x plus 6 times 3x minus 5. First binomial, second binomial. Binomial is an algebraic expression that contains two terms, right? First term, second term, first term, second term, binomial, binomial. So if we try to take the product of this, okay, sometimes we joke sometimes easy money, right? So if we try to bring out the solution, the product of the quantity x plus 6 times the quantity 3x minus 5, okay, it will be x times the second binomial, okay, plus 6 times the second binomial. Then try to apply your knowledge of the so-called distributive law. Of course, plus some other laws of exponents. And x multiplied by 3x will be 3x squared. X times negative 5 will be negative 5x. 6 times 3x will be plus 18x. 6 times minus 5 will be negative 30. Okay, roll in the simplification. Try to combine similar terms. For 3x squared, it is alone, right? But for the x terms, there are two x terms. It is negative 5x and plus 18x. We add those ones, okay? A negative 5 plus 18 will be plus 13. So the coefficient of x will be plus 13. Because this plus here is bigger than this minus, so this should be plus. And for the pure constant term, it will just be simply negative 30. So the last part is actually negative 30. So meaning the expansion of these two binomial, after the expansion, okay, it will be 3x squared plus 13x minus 30. Okay, that will be our answer. We joke sometimes, easy money, okay? There's no big deal on that one. Okay, let's proceed with the next one. Square of a binomial. So meaning to say we are a given binomial and we try to expand. So actually, binomial, another binomial, but this is preceded by plus, this is preceded by minus. An x plus y quantity square, actually later on when we go to the so-called binomial theorem, you could visualize that this is the expansion actually by recalling the binomial theorem, but we are not yet on the topic binomial theorem. So to expand this one, okay, so it will be an x squared plus 2xy plus y squared. Or you just multiply it by longhand like that, x plus y, right? X times x will be x squared, x times y will be xy, okay? X times y will again be xy, so there will be 2xy, right? So this is 2xy, and the last part will be the product of y times y, which is y squared. Okay? Oh, that's how we multiply a binomial or squaring a binomial. But if the other one, the sign of the middle term is actually negative, it should be the same. If this is minus, this will now be minus. Okay? X times x will be x squared. The middle term will be negative y times x will be negative xy. And negative y times x will still be negative xy. And a negative y and negative y will be y squared. Minus xy will be negative 2xy. So actually the middle term is negative 2xy. Again, it's an easy one, right? Okay? Okay? An example of this, it will be expand x minus 9 quantity square. So x minus 9 quantity square, it will be the square of the first term. Okay? Since the sign here is negative, it will be negative twice the product of 9 times x. This is 9 times x. Right? And the last part, actually, you can write this one as x plus open quantity negative 9 all quantity square. So if you try to bring out the square of the last one, it should be negative 9 quantity square. Right? So don't be afraid with this negative sign because we could write this one as same as the number 1 binomial, right? In which the sign of the second term is 9, but the operation there is plus. Because a plus in a minus will still be minus. Okay? And if we try to expand this one, it will be an x squared. It should be negative 18x. Negative 9 squared is actually plus 81. As simple as that one. So we got no problem with the product of a binomial, the square of a binomial. Okay? So this lesson will be an easy for us, right? But the next ones will be a different one. Okay, the third classification, the product of sums and differences. Meaning to say, the sign of the first binomial is a plus, that's why sums. And the sign of the next binomial will be minus, so this difference. So the problem is asking if we try to multiply a sum and a difference, what will be the product? Oh, that's an easy one, no problem. You can use longhand if you don't like to memorize this one. Okay, so an x plus y, what's happening? An x plus y, that's sum. And x minus y, okay, that's difference. So if we try to multiply with this, that's why we are under special products multiplication. Or just perform the operation, right? X times x will be x squared, right? The product of x times y will be plus xy, and the product of x times negative y will be negative xy, and the product of the last one will be a plus y times a negative y will be, the sign will be negative, right? And y should have the power 2. And unluckily, for the sum and difference, actually the middle part cancels. So what comes out will just be simply x squared minus y squared. So if you are seeing this form of equation while you're having an examination maybe, okay, you just go directly with x squared minus y squared. For me, I don't even have to think of this. I will just perform the multiplication and I could bring out that the product of this sum and difference will be an x squared minus y squared. I got no problem with that one. So actually, I don't have to memorize this one. I will just perform the operation and I could bring out the resulting right hand side to be an x squared minus y squared like this. Okay, that's it. We don't have to bring out, okay, well, we got an example. Find the product of 2x plus 5y times the quantity 2x minus 5y. First binomial preceded by plus, second binomial preceded by minus, right? And if we try to multiply this one, okay, we'll follow this immediately. It will be the square root of the first one plus the square root of the second one, okay? But this is plus and a minus, so the sign of the second one will be negative. So it will be 4x squared minus 25y squared. And if you don't want this solution, you just perform the operation 2x plus 5y times 2x minus 5y, right? Okay. 2x times 2x will be 4x squared. 2x times 5y will be plus 10y. 2x times minus 5y will be minus 10y. And 5y times negative 5y will be minus 25y squared. So actually the middle part cancels. So what comes out is just simply 4x squared minus 25y squared. So this is correct, right? So, but for me, I don't have to memorize this. So the answer is just a 4x squared, the square of the first one, minus the square of the second one. Okay, that will be our answer. Okay? The last topic for this morning, cubes of binomial. Meaning to say, we are given a binomial and it is raised to the third power. So it seems we are now on the so-called binomial theorem, but not yet. We are not yet on the binomial theorem. Okay, cubes of binomial. First binomial is x plus y. This is to the third power. The second one, so it seems we are still under the sum and difference, but instead of just multiplying, this is cubes, right? So it is raised to the third power. If we try to expand this one, actually I could check this one that this was correct because in my mind, I am what you call this, imagining the property of a binomial theorem, alright? But for the meantime, we are not on the binomial theorem. So if we try to expand this one, it will be an x cubed 3x squared y plus 3xy squared plus y cubed. Okay? And for the second one, they're actually the same, but since this is minus, the expansion of this x minus y to the third power will be in the sequence positive, negative, positive, negative. So they are actually the same, except that this is negative and the last part is negative. Because a negative y to the third power will be, you multiply a negative value 3 times, the sign should be negative, so this is negative. And so with the second one. Okay? If you don't want to memorize this one, okay, you just do like this. It will be an x plus y. The other x plus y is actually a square of a binomial, right? So this is multiplied by the square of this. So you can place this x squared plus 2xy plus y squared. Okay? Then try to distribute this one. Okay? I will not do it now because we know that the result will be this one, right? Okay? So if you try to expand this one, x times this, plus again y times this, and if you try to simplify, it will be this one. Okay, as simple as that one. So we got no problem with the cubes of binomial, right? An example of this, an x plus 2 raised to the third power. Okay? If we try to follow this, it will be the cube of the first one plus 3 times the value of the first one to the second power times the value of the second one to the first power. Well, I'm following this. Plus 3. This is to the first power. The power of the second one should be square. And the last part will be the pure number to the third power. Okay? So if we try to simplify this one, it will be an x cubed 6x squared. 3 times 2 will be 6 times x squared. 3 times 2 times, or 3 times 2 will be 6, or 4 square is actually, 2 square is 4, right? Times 3, that will be 12. So the coefficient of x will be 12x plus 8. So that this will be our answer. So our topic for this morning were all multiplications, and in college algebra they call this special products. Okay, I will repeat it for the last time before we go with this morning. The product of two binomial, the square of a binomial. The third one is the product of sum and difference of a binomial. First binomial, second binomial, but this is plus and this minus, that's why it is sum and difference. And the last part is the cube of a binomial. Okay? If you could memorize this one, for the meantime, no problem, right? But for me, I will not try to memorize this one. I will just use the expansion method. Okay? And I could bring out this one. But if you are smart enough to insert it in your mind, there's no problem memorizing the expansion of x plus y to the third power and x minus y to the third power. Actually, they are the same. Only that for the negative sign, the sign is actually alternate. I mean the sign. It is plus minus, this plus minus. Okay, good morning from Los Angeles. This is Professor David J. De Los Reyes.